In this section, it is again really just taking everything we have learned, mix it all up, and throw it into a document for you. What I'm really hoping you do is pause the video a minute, try these up to where it says solve. So there's 4 problems I would love to see you try by yourself. I then will work them out. We'll, so to say, talk about where you and I may or may not do things the same. We do them a little different. So please pause the video, give them a try, the next 4 problems, and then I'll reveal my answers and how I approach them. Pause the video. Thank you for pausing. Okay, I see a binomial here. So first, I might ask myself always, can I make it simpler? I just want to make things simpler. Is there a greatest common factor here? Yes, I see a greatest common factor of 6. So I would distribute backwards and I'd have x squared minus 16. So I did simplify it. I did factor it. But before I put a box around my solution and say, am I done? I need to say, whoa, I see another binomial with a subtraction sign. I wonder, is this a perfect square minus a perfect square? It is. Dropping down the 6, x, so I would have, almost wrote squared again, I would have x minus 4 times x plus 4. The square root of the first term, the square root of the last term. Okay, what if you didn't think of 6 as the greatest common factor? You thought of 2. If you factored out 2, you would have had 3x squared minus 48. Again, before I put a box around my final answer, I will make sure, can I make this simpler? Ooh, well, 3 goes into 48. So if I take that 3 out, I have to multiply it by the 2, so I would end at 6. X squared minus 16. 3 times 16 is 48. And that would put me here again. It's okay if you didn't find 6 at first, but you have to keep asking yourself before you're done, can I make it simpler? Can I make it simpler? So this would be my final answer, different ways to get there. For the next one, binomial minus a binomial. So can I make it simpler? Yeah, I can take out a 5x. If I take out a 5x, I'm left with 3x minus 4. And can I make that simpler? No, I'm just done there. Okay, first question. I know this is a weird word. I should ask for greatest common factor, but I like a simple word to remember. Simpler. Can I make it simpler? No. Is it a perfect square trinomial? Is that a perfect square? Yes. Oh, never can you have a negative sign there. And 15 is not a perfect square. All right. My last choice would be try the ACB chart. Before, don't use that word prime too early. I have to take 16 times negative 15, and I get a negative 240 that have a sum of 8. We can list all the factors with a sum of 8. You know, it would be negative 1 and 240, negative 2 and 120, negative 3 and 80, negative 4 and 60. Sheesh, negative 5 and, let's see, that would be 48. And I could have negative 6 and 40. 7 doesn't go in there. negative 8 and 30. Ooh, I'm running out of room. 9 does not go in there. 10, negative, let's see, negative 10 and 24. Ooh, closer. Oh, how about negative 12 times 20? That would work. After all of that, negative 12 times 20. So here's my A term. These would be my B term. That's the C term. Doesn't matter which one of these I write first. No. These two make the B, and that's my C. Step 1 will not change. Group. Take out the greatest common factor. Here would be 4y, leaving me with 4y minus 5. Greatest common factor would be a plus 5. So I would get 4y minus, whoops, I was planning ahead too much. This needs to be a 3. I knew that I did a mistake. If you did that, how would I know I goofed somewhere? It's because of the third step when I need identical. I wouldn't be able to get out my handy dandy highlighter, and if I can't highlight, I've got a problem. So that told me I needed to go fix something. Put your greatest common factors together and one set of your identical. Phew. Okay. Again, if you chose not to go through the perfect square things here and jumped right to the ABC chart, that is fine. Now we're going to try this again. First question. It's that weird word, simpler. Can I make that simpler? Well, there's not very many numbers that go into 35, so I'm going to say no. If you want to test to see if you have a perfect square trinomial, right away I know 8's not a perfect square, neither is 35, and you can never have a perfect square that is negative. So I need to bust out my ACB chart before I just say, oh, it's prime. So 8 times negative 35 gets me negative 280. That adds to negative 18. Well, we could make that list again just like we did in the last problem. Please do that if you want. What I know when I look at this is that negative 28 times 10, because I can multiply by 10 pretty swiftly, would get me a sum of negative 18. So 8x squared minus 28x plus 10x minus 35. It does not matter what order you put this for your B term. You could have plus 10 here. You could have negative 28x there. It will get us the same answer. So step 1, and group. So I'm going to group these together. And I would take out a 4x, leaving me with 2x minus 7. If I accidentally thought 2, because they're both even, is my greatest common factor, I would have had 4x minus 14, and hopefully I would have been alerted when the greatest common factor isn't 1 there. So I knew I had to do better. My greatest common factor here is a 5, so I get 2x minus 7. Oops, I forgot to write down that step. Okay, so from there we are going to do identicals, which we found, and I'm going to get the highlighter out because that is still, after all of this, very exciting for me. It's a way to check my work. And that would be my final solution.